So we're going to talk about electricity. We have got a couple of big ideas we want to get. Today we're going to give you the basic concepts, and we are going to relate three variables together, and we're into one equation. So we've got to give you those three concepts. Hopefully you've read about this in chapter 34 already. And then we're going to give you the equation, Ohm's law. We're going to break this up 4 videos so that we can talk about voltage, current, resistance, and then we're going to tie them together in a 4th video, Ohm's law, so that we can make this all pretty small. I'm going to make one recommendation for you guys in order to help organize and keep things straight. You could just reference back to the book, but it might be helpful to have a little cheat sheet together in order to tie everything together and sort of summarize everything. So I'm going to recommend looking at it this way. We are going to be looking at 4 basic important things for each thing. So we're going to have the name of each concept that we refer to. It is going to have a basic idea tied to it. Mathematically, we'll use a variable to represent it. And for every number, we need a unit to give it meaning. And so what I recommend is, as we go through these, fill out a table that looks something like this. I'll go through and I'll fill this out myself here so you can see how I'm organizing it. And then we can talk about it. So the first thing that we've got, and what this video is going to be about, is going to be something called voltage. And so when we're looking at voltage, that is basically the strength of current. We know that charge wants to travel. You've researched electricity in the form of lightning. And so if we look at just static charges, we know that if there's a big difference in charge between one place and another, it's going to want to travel. If we were to measure that difference in charge, that would be what we would call the voltage. Now, when we're looking at consistently flowing charge in the form of electricity, it's not going to be one big jump like a static shock or an electric lightning strike, but it is going to be constant. So we're going to use water as an analogy here. So if you envision a stream or water in a pipe, that gives you an idea. So if we are looking at voltage, we are going to, we're going to call it voltage. And that's the name that we're using here. So I'm going to update my little table. The name of this is voltage, and that's how it'll be referred to. So here we go. We are looking at, got my hand over it. There we are. Voltage. So voltage is the name. For the concept, if we wanted to break that down really small, we might call it 2 ways of thinking about it. We could just say it's the strength of current. Or we might also say, call it electron pressure. Like we could talk about water pressure. We could talk about this as electron pressure. How much force or how much difference in charge is making those electrons want to flow. So we've got the strength of current and the electron pressure. Now, that is going to be represented. Let's see if I can write this upside down or backwards here. Let's see if you guys want to see me struggle. Let's see if we can do this. So we're going to call that just V. We're going to use the variable V to represent voltage. And then I actually need to write out a word here. Voltage, handy enough, is represented by this unit volts. Voltage has units of volts. And the variable actually matches the unit in this case. Don't get too comfortable with that. But volts is represented by a capital V. So voltage is the strength of current, which we could think about as electron pressure, represented by the variable V with the units of volts, also V. Make sure you have that in your head or get it written down. I'll see you in a little bit and we will talk about current.